Hey everybody, today we have one of these infamous simplify problems, and about all we have working for us in this problem is that the radicand is in the form of a difference of two squares. Now, we're actually hoping that when we apply this formula, one or more of the factors will be a perfect square, so you can take the square root of a perfect square and get an integer back. So anyway, this super popular identity holds for all complex numbers and real numbers, I guess. But a plus b is one of the factors, and a minus b. And it's well known that the middle terms cancel. ba and minus ba cancel here. Okay, so again, we're rooting for either a plus b or a minus b to be a perfect square. That way we can take its square root and get an integer. Okay, and that's really how you do these in general. Now, it's hard to discern what's going on here. At this point, it's not just 387 squared by itself, which the answer would be trivial 387. It's 387 squared minus 97 squared. And as you can see below, it works out quite nicely because this 484 right here happens to be something squared, 22 squared. 22 squared is equal to 484. And of course, the square root of something squared is the something, right? And so if you carry on down here, let's see, we need to finish this off. So that will be 22. Okay, the square root of 484 is 22 per this statement right here. So we would have 22 times the square root of this difference here. And let's see, I think that's 290. Okay. And we have to check to see if this has any, if 290 has any perfect square factors. Notice that 290 is equal to 2 times 145, I believe. Okay, so there's not any perfect square factors in 145. 145 is what, 5 times 29? This is equal to 5 times 29 here, right? So it's not definitely no 25s going on there. 5 times 29, 100 plus 45. Okay, so we can't simplify the 290 anymore in terms of reducing or simplifying the radical. So this is the final answer. Now you may be asking, so what? Well, just think of it from a standpoint of approximation. You have no idea what this number is in terms of what number it's even close to, right? You know it's something less than 387, right? But then you're subtracting an awful large number from another awful large number. So what does this really tell us? This result right here tells us that this is approximately equal to, and that's a lazy equal sign, 22 times 17. So you see, we got a nice integer approximation. And you may notice, well, where did that come from? Well, 17 squared is 289, which is very close to 290, close enough to make this a decent approximation up here. So again, a so-called application or practical reason why you'd want to do that, at least you have some idea. You know it's very close to 22 times 17. You can check it on the calculator if you want. But that's something you wouldn't know unless you follow this procedure or something else. There might be some other way to do it. But again, these kind of problems are designed to work. You know, one of these factors has to be a perfect square. You wouldn't even be getting to first base really in terms of simplifying it. So anyway, the final answer is 22 times the square root of 290. Hope you enjoyed.